That's right, Joey. 4 and negative 2 would make that thing equal to 0. The only thing that makes this tricky is you're not so much worried about where it's going to equal, but where it's going to be greater than. Well, let me ask you this. Is there anything here that's going to make this function discontinuous? Now remember, the only thing that makes functions discontinuous is a 0 in the denominator or something under a radical, neither of which are even occurring here. So, is there anything there that's going to make that function discontinuous? No. So what is the only... Now let's think of what this says. Think about a graph. What does it mean for a function to be greater than 0 at a given point? Who can put that in words for me? What would that look like at a given point if I said, is the function greater than 0 there? What am I asking you on a graph? Is it positive? Is it above the x-axis? Exactly. And the only way something can go from positive to negative is by crossing the x-axis, assuming it's not discontinuous anywhere, which this one isn't. So what you needed to do were just to find the zeros, boom, boom, and here's essentially what we're looking at here. If you FOILed this out, you probably saw that it was a parabola, an upwards parabola, if you bothered to think at all about the end behavior. It's crossing at negative 2 and positive 4. And just by knowing what the parent function looks like, you could have assumed that it looked like that. So at what values of x is this thing greater than 0? Yes, that's true. 5, it does make this true. But just looking at the graph, think of it in terms of domain. What domain is that thing where it's going to be greater than 0? X is what? That's right. Negative infinity to negative 2. Or another way to put it would be x is less than negative 2. Would also make that where it's greater than 0. And what's the other one? 4 to infinity, or x is greater than 4. Very, very good. That's what you're going to do today. Now, let's say you're like, oh, darn, I never really thought about the graph. Easiest way to do these problems today, because that's exactly what we're doing all day today. And we're going to throw in a few more little curveballs, but that's essentially what we're doing. Easiest way to do it is to know what the parent looks like. And then, if you knew that this had up, up in behavior, and after you FOILed it out, you could have seen that it had a y-intercept of negative 8, roots of 4 and negative 2, you can just visualize the graph and be like, oh, it's going to be greater than 0 here. Or this might have said less than 0, in which case it would have been less than 0 between negative 2 and 4. Now, not all of them today you're going to be able to do that, because they'll have a denominator, something that's going to change up the equation. So here's what you're going to need to be doing today. The most universal way to do this, if you don't want to do the graph, or just this method will work on every problem. Make yourself a number line. Make yourself a number line. Now you are going to mark today every single point where this thing might go from positive to negative. The only way a function can go from positive to negative and cross that axis is when it's going to equal 0, so where the roots are. So in this case that would be negative 2 and positive 4. I'm just making myself a number line. And the only other way that a function can go from positive to negative or vice versa is where it's discontinuous. So like say this whole thing had been over x plus 3, then negative 3 would be a potential point. Now once you have that number line, you're going to test it like this. You know it crosses here, but assuming you don't know what the graph looks like, you don't know whether it's going to be greater than 0 here, greater than 0 here, greater than 0 here. You don't know that. You just know that those are the 3 intervals where it might possibly change. So you're going to plug in numbers, just like what Austin said. You're going to plug in numbers in these ranges, or excuse me, domains, and just see. So if I plug 0 into this function, what's that going to be? Negative 4 times 2 is what? Negative 8. Is negative 8 greater than 0? No. So you would have been an x right here. I'd plug in a number over here, like 5. That'd be 1 times 7. Is 7 greater than 0? Yes, it is. I'm going to plug a number in this range, like negative 3. That'd be negative 7, negative 1. Is positive 7 greater than 0? And that's how you're going to find your answers. You're going to make a number line, mark every point where it might change, or will change, and then test your intervals. So this will tell me x is less than negative 2, x is greater than 4, are my two intervals where I'm going to be greater than 0. That is basically how you're working every single problem today. Only difference is that they'll all look a little different, and we'll look at some examples. What was the answer? Okay. Well, there's two ways to write it. How I would have written it is x is less than negative 2 and x is greater than 4. Start up some notes for 2.7 and pass up your DOMs, please. Pass up your DOMs. Your next test will probably be in the late next week, Wednesday or Thursday of next week will be your next test in this class. I'm going to go with Wednesday right now. Don't forget to turn in your homework if you haven't done so already. Yes, ma'am. Thank you. The lesson and assignment will be online in the next class. Is there any more Dons still making their way up? Any more Dons? All right. Excuse me? Yeah. All right. So let's just look at the first batch of problems. Never mind. That's not. Yes, it is. I don't know why I started with 71. Probably because I just wanted us to visualize this. You are going to have problems like this today, where it actually shows you the function and asks you to figure out where that inequality is true or not. And when that happens, it's the best case scenario. See you Monday. Now, today, easiest way to do these is to make them all equal. I say equal, but put them all on one side and 0 on the other. If you're comparing to 0, it's easy. Then all you have to look at is it above or below the x-axis. So let's move everything to one side. That'd be 2x cubed plus 11x squared minus 7x minus 6 is greater than or equal to 0. Which they've already done for you right up here. They already went ahead and did that, but that's going to be our first step. Anytime today where you have things on both sides, move them all to 1. Easiest when you compare it to 0. So what are we looking at? We're looking at where this whole thing is greater than 0. We'll look at the function. Where does that occur? Looks like that's 1, 2, 3, 4, 5, 6. So it looks like that's from about 6 to, looks like about negative 1/2. So from 6 to negative 1/2. Why am I putting equal signs on this instead of just a normal greater than or less than? Because that's what it is in the problem. You'll match the inequality in the problem. If it's equals, you'll be equals. If it's not, you won't. Yeah. It would. Thank you. And where else is this thing going to be greater than 0? That's right, 1 to infinity, or x is greater than or equal to 1. I would accept it the way you wrote it too. But I think that's how it's going to be on the test, so that's why I'm writing it. But that's fine. Raise your hand if you're like, Mr. Crawford, where are you getting those numbers? How are you getting those numbers? That question? Okay. So, we're looking, the beauty of making this thing on one side of the equation and 0 on the other is you can just look at where it crosses the axis. Okay? Now, when I move these two things over, that's going to be greater than or equal to 0, right? So I'm looking for where it's going to be above the x-axis. So that looks to be, that little loop right there is above. And I eyeballed that to be about negative 6 and about negative 1/2. And so, greater than negative 6 and less than 1/2. And that domain is above the x-axis. And then, looks like from about 1 to infinity. So all x greater than 1. Now, if you want to answer it the way Joey's been saying it, that's fine too. I think he's like, remember how we did domains earlier in the year? If you wanted to write it like this, that's fine. -6 bracket to -1/2 bracket, and then 1 to infinity bracket parentheses. I'm not entirely sure which way it'll show it to you on your test, but if you prefer to do it like domain style, like we did earlier in the year, then by all means do so. I don't think it makes a difference. In fact, now that I think about it, it might be like that. I'll just keep going back and forth because I'm not interested. Questions on that problem? That's going to be one of the very, 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 very few that'll give you the picture. The rest of them will just give you the function, like we've been working with all chapter, and you have to find these values where it equals 0, which is what we've been doing. Rational root theorem, synthetic division, all that stuff was finding our roots. Okay, 1 through 42. You can see these are big sections. 1 through 40. Solve each polynomial equation, then graph the solution set on the real number line. Okay, we just did number 1 in the DOM. We have to find where these things could potentially cross the axis by finding its zeros and test the intervals. Every single problem on this screen is a quadratic. So you can just do the quadratic equation to find those values. Let's look at 17. Number 17. Now, just like I said a second ago with the one that was graphed, what's our first step on all of these? Yeah, function one side, 0 on the other. I think it's going to have to be one of those days where people can speak once, and then I have to go to somebody else. Jared, you have spoken. Thank you. I'll have to wait for other people next time. So, I'm going to move the 3x squared and the 2 over. It doesn't really matter which direction you do that in. You'll get the same thing. Is less than or equal to 0. I just added the 3x squared, subtracted the 2. Now, for your purposes, don't even worry about the inequality yet. Think about it as if it said equals 0. How do you find the roots? Quadratic. Thank you, Drake. Now you are off the speaking hook. Negative b plus or minus b squared minus 4ac all over 2a. So that's negative 5 plus or minus 24, 25 plus 24 is 49 over 6. So it's negative 5 plus or minus 7 over 6. Negative 5 plus 7 is 2 over 6 is 1/3. And negative 5 minus 7 is negative 12 over 6 is negative 2. So those are your 2 points where it's going to change from negative to positive or positive to negative. You don't know which yet. So the second part says, do your solution set on a number line and figure out which ones it's true for. So here I go. Alright, number line. Only 2 points I need to check around are negative 2 and 1/3, because that's where it's going to equal 0 and cross the x-axis and change from positive to negative. Now, am I looking to see where it's going to be negative or positive? What am I looking for in this problem? Where it's going to be negative? That's right. Zach's first one I heard. You are off the speaking hook. Thank you. I'm hoping it's going to be negative because I am less than or equal to 0. So, what's a number in the left-hand side that I can plug in? Is that you, Joey? You are off the hook now, too. Negative 3. Let's plug it in. I didn't really leave myself a lot of space here. So if I plug negative 3 into this equation, which you can do by plugging it in or using synthetic division, whichever you're quicker with. Remember, that was the whole purpose of the remainder theorem. I'm going to use synthetic division. So I'm plugging in negative 3. And I want to find what it's going to equal when I plug that in, which is the same thing as dividing it out. 3, negative 9, negative 4, 12, and 12. Am I positive or negative? Come on, these are the easy questions. Y'all need to jump on this. Am I positive or negative? Josh, the first person I heard, you are off the speaking hook. Thank you. Jump on the easy ones, people. So, did that satisfy my equation? Is 12 less than or equal to 0? No. X. What's the number in here I can check? What's the easiest number in this domain I can check? And if y'all talk louder, I could... Savannah, you're the first person I hear say 0, so you are off the speaking hook. So I'm going to try 0. Plugging that in, that'll be 0 plus 0 minus 2. Is negative 2 less than or equal to 0? Yes, it is. Does anybody have a hunch about what the next one's going to be? It's going to be an X, yeah. You can use what you know about graphs. Did this root occur twice when I was looking for them? No. So it's not going to think about what would a check look like on a graph. That means you would touch the 0 and go right back below or above. But it didn't occur twice, so I know it has to cross. Use things you already know to make this easier on yourself. X check X. But for the sake of it, we're going to go ahead and plug in a 1 and see what we get. 3 plus 5 minus 2 is 6 less than or equal to 0. No. So our answer, again, you can put it domain style. Let's see, this was with an equal sign. So negative 2 to 1/3 would be one way to write it. Or you could write negative 2 is less than or equal to x is less than or equal to 1/3. Either one of those would suffice as your answer. Only place to satisfy this equation was in that little piece of domain. Questions on this one? We're going to go with the whole hand raising thing for these historical questions. Yeah. What do you mean? You could have. You could have. I personally, since you don't get to use graphing calculators in your test, I actually think it's hard to think about with negative 3 squared times 3, to keep all that in your mind. I think it's easier just to use synthetic. But if you want to plug in negative 3, you can. That's perfectly fine. But when it's a number other than 1 or 0, I prefer just to use synthetic division. But the option is yours. Questions on that problem? That was a good one. All right. All of these are going to work that exact same way. In my opinion, that's the hardest one on the page. So if there's no questions on that one, we'll just move on. All right. Here are the rest of the ones in that same section. 19 through 27 are the exact same as the one we just did. They're just quadratic. 41 through 29 are a little different because there are 3 of them. Now, 29 and 30, there's really not a whole lot to do. It's that the 3 roots are staring you in the face. 29, the roots are 1, 2, and 3. That's what you put on your number line, and you check all your intervals. Done. Same thing for 33. 2 is a double root. What does that mean? That means when you do your number line and you go on this side of 2 and on this side of 2, you're going to get the same thing because it's touching there. It's a double root. Use your context clues. Let's look at 35 through 41. Let's look at one of those. Somebody raise your hand and pick one of those. Shelby. That wasn't in the range of problems that I gave you. Okay. 37. 37. So, we need to find how many places is this thing going to cross? Or potentially cross? 3. Yeah, the degree. Now, if you get imaginary, that's awesome, because you don't have to check those, because they're not going to cross there. So we're hoping for imaginary roots here. All right. You can use any of the techniques we've used so far to solve this. You can use the rational roots theorem to find one, and then use quadratic. You can factor by grouping if you know how to do that, if this one even does that. Anything you want to use. I'm going to do this one by factoring by grouping. So, boom, 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 boom. So, what factors out of x cubed minus 3x squared? What factors out of x cubed minus 3x squared? Holly. X squared. You are off the hook. Thank you. Leaving me with, actually, I'm going to Probably to finish this. What's that going to leave me with? Very good. What's going to factor out of the second piece? Negative 9x plus 27. Yes, sir. Oh, you can't answer. You've already answered. Sabrina, I don't think you've answered yet. What did you say? 3. A 3 would, and you'd be left with 3 and then negative 3x, which another 3 would come out of. So let's just go ahead and take them both out at the same time and make that a 9. So it'll be 9, and what will be left is x plus 3. Are these the same sign? Oh, that'd be a negative x plus 3. Excuse me. Are these the same sign? No. When you factor by grouping, you really want them to be. So let's take out a negative 9, and that'll make this a positive x and a minus 3. Now we have the same binomial. So that becomes x squared minus 9 times x minus 3. How does the left-hand portion factor? Thank you, Troyan. You are off the hook. So, logic time. What are my roots? And list all the times that they occur if one occurs more than once. Raise your hand to tell me. What are my 3 roots here? Kayla. What's the third one? It's positive 3 again. Remember, it's whatever makes them 0. Why does it help me to know that one of them occurs twice? That's right, it'll touch. So on my number line, I know, here's what I know. Without even checking these, I know I'm looking around negative 3 and 3. I know it's going to look something like this. Check x, 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 check, check. It's got to, because I know it crosses here, so it's going to change, and I know it touches here, so it's going to be the same. I just don't know whether it's checked in 2 x's or an x and 2 checks. So I have to find one. Use those pieces of knowledge to your benefit. What's the easiest number to check on any function? Let's try it. If I plug 0 into my original, I get 0 minus 0 minus 0 plus 27. Is 27 less than 0? No. So which interval is that? Left, right, or middle? Middle. So that was an x. And just by knowing where it crosses and touches, I can figure everything else out. It crosses here, so these have to be different. And it touches here, so these have to be the same. So what is my answer in a solution thingy? How would I write my answer, in other words? This is an easy one. Somebody can get off the hook for free here. How do I write my answer? What's the domain for which this is true? Yes, ma'am. Except there's no equal sign. But, very good. X is less than negative 3, or another way you might write it is negative infinity to negative 3. Either one of those will work. Thank you. You are off the hook. Some of y'all are going to have to step up, but we're going to be working all day. Very good. Questions about any way that we work this, or any way we made a certain conclusion about anything we've done, please ask a question. If you do not like to factor, that's fine. Do your rational root theorem. You would have gotten plus or minus 1, 3, 9, or 27. You would have tried those. You would have found that 3 or negative 3, whichever one you came across first, worked. You would have taken it out using synthetic division. You would have been down to a quadratic, and you could have done the quadratic equation to find the other two. Either method will work and get you the same thing. Questions about anything that's on this board? Is there one that's on this board that you're like, I don't think I would see, how that one relates to the others? Can you explain how we've worked that one? Anything like that? Any one on this board that you think looks different than the others? All right. Good, because they're all going to work the same. These pre-factored ones you should learn to love, because those are really awesome. 31. What are my 3 values I'm going to be testing there? Who said that? You are off the hook. Very good. 0, don't forget, when you have a raw x, it's just 0. 0, 3, and 5. Excellent. All right, next slide. Uh-oh, denominator. Denominators aren't a bad thing, though. Because what happens when I have a 0 in the denominator? Think about what we did yesterday. On a graph, when you have a 0 in the denominator, what happens? I'm kind of motioning it with my little arm. What do we call these? I'll give you a hint of few and silent. Good job. You are off the hook. Vertical asymptotes. Any place where you have a point of inequality on a graph, that's another place where you could go from positive to negative. Didn't we have vertical asymptotes yesterday? That I'm just going to sketch one real quick. Like, say we had one here. Didn't they go like that? Notice it goes from negative to positive without having to cross. So that's another point we'll have to check because it'll be changing from greater than to less than. Now, the only thing that makes vertical asymptotes a little bit more annoying than roots are you can't just make those assumptions by XX or X check. You can't. You might have come in the same on both sides. You might alternate. You're just not entirely sure. So you're going to have to check some more intervals here. Okay, so that being said, let me get rid of that. No, each dot individually. All right. Eeny, meeny, miny, 45. Who can raise your hand and tell me what two values you think we're going to be testing on number 45? You're worried about where it's going to be impossible and where it's going to equal 0. Then, negative 3 is going to make it equal to 0, and negative 4 is going to give me a vertical asymptote. Very good. You are off the hook. So you would make your little number line, and you would check negative 4 and negative 3. Unfortunately, it looks like you're going to have to try a decimal in between those, because there's no numbers between them. What's the easiest number to check every time first? 0. Is 3 over 4 less than 0? No. X. Let's try this interval. Negative 5. That'll be negative 2 over negative 1. Is 2 less than 0? No. Now, I'm sure most of you are like, I bet that middle one's a check. And it probably is, but you still have to check it because you can't assume things about vertical asymptotes. You can assume that this is just a normal old 0 of the function, so it is going to cross. And you'd be correct in saying, well, that means these two have to be different. But for the sake of being safe, because the problem is, we're going to have problems in a second where there's like 3 things in the bottom and 2 things in the top. You're going to have lots of intervals. So unless you're going to like mark over here which one's an asymptote, which one's a 0, it's best off just to check all of them on these problems. Okay, so what's the number in between negative 3 and negative 4? Negative 3.5, exactly. Let's plug it in here. Negative 3.5 plus 3 is negative 1/2. Negative 3.5 plus 4 is positive 1/2. Negative divided by positive is going to be what kind of number? A negative. Is a negative going to be less than 0? Yes. So, how do I write my answer? Free chance for somebody to get off the hook here. Here's the actual answer. How do I write it? I'll sit here all day. Yes, sir. Excellent. X is greater than negative 4, and x is less than negative 3, or you could just say negative 4 to negative 3, double parentheses, because it doesn't touch either of those with no equal sign. Either of those will suffice. Thank you, Austin. 43 through 51 are all like that. 51, you need to check 0 and 3. 47, you need to check 2 and 4. If you think one looks a little different, then take the time to actually set it equal to 0 and solve for x. 49, set this equal to 0, set this equal to 0. That's going to be like negative 4/3. That's going to be like 2. So there are your two values. Then you just work around them. Questions about anything you see on the board about what you're going to be looking for? All right. We only have one slide left. I'm guessing it's going to be the granddaddy problems. Actually, these don't look that much harder. 53. What 3 values am I checking? Olivia. Really? 55. Oh, 55, 57, 59. They're the same thing. Same thing. But, like we said, it's going to be easiest if you do what first? That's right, move it over. Here's the only thing that's going to make these things a little more challenging. You can no longer just say 2. Because, let me show you why. Let's look at 59. Actually, I take that back. Let's look at 57. That one looks to be the trickiest. When you're not set up for 0, if you have a random number, it complicates things just a little bit for this reason. Watch. I went ahead and moved the 3 over. Now, you can't just say -4 anymore, because that's going to give you 0 minus 3, which, you know, it's no longer a 0 of the function. It now equals -3. If you were setting them equal to 0, looking for the roots. So, you are going to, well, you can do 2 things. You can set this whole thing equal to 0 and solve. My mind's had a complete brain freeze. Is the bottom number going to be affected at all? No, what's going to make the function impossible is not going to change. So you can still find this one. 2x minus 1 equals 0. Add the 1. Divide by 2. So 1/2 is a number we need to check. Now, to find the other one, you're still going to want to come back and check it like this in a minute. But it might be easier for you to go back here and solve for x and see what's going to make this thing equal. So, I'm going to multiply this to the other side. Remember, we're just assuming this is equals right now. We're not even going to worry about the inequality for this moment. That'll be x plus 4 equals 3 times 2x minus 1. That's x plus 4 equals 6x minus 3. Subtract the x, add the 3. Divide by 5. So 7/5 is the other number we need to check. Once you've got that, it goes right back to being just like everything else we've done. Let me, I'll just do it down here. So my number line is going to go from 1/2 to 7/5, and you're just going to try it with your, actually I take that back. It's probably easiest to try this with this one, although it doesn't really matter, I guess. On the ones where you have a low number, I don't guess it matters which equation you use. What's the easiest one to check? 0, which would be here. Dang it. Alright, plugging in 0. That gives me 0 minus 3 is less than or equal to 0. Is that a true statement? Yes. What's an easy number to plug in between these two? 1. Very good. If I plug 1 into my original, that gives me 5 over 1 is 5 less than or equal to 3. No. What's a number I can plug in on this side? What's a number greater than 7/5? 2. So that's going to give me 6. 4 minus 1 will be 3. Is 2 less than or equal to 3? Yes. And boom. There you're done. It'd be greater than 1/2, less than 7/5. Only thing that makes that thing trickier is finding this part, which you're best off doing just by setting that to an equal sign and solving for x. Multiply it over, and then you do your algebra. It's a lot of info for a Friday. Don't you agree, Shelby Emmons? Yes, you do agree. Questions? All right. I can tell you guys are really eager to get to work. Fine. There you go.